Hello everyone. I'm audible. Please, can anyone confirm so that we can start the session? Okay. Okay. So let's start the discussion. So hello everyone. I'm Ayush Shukla and I'm DSA mentor at Geeks for Geeks. So I will be taking your session that is Biwizard contest analysis, and I will be discussing all the problems there. That is 10 MCQs and the three problems that we are getting. So Uh, firstly, we can have the how was the session. We can have the in the chat section so that I get what were the problems there. Can we have a quick +1 in the chat and as well how was it your contest experiences so that we can start. Okay. Okay. Let's move to the contest discussion. So I will be discussing firstly the MCQs there, and then we'll be moving to the coding questions, right? So let's start with the MCQs there. Okay, so we have 10 MCQs in the session, and those were the that is we are given here. Okay, the very first question of the contest that is MCQs was in your school economics is taught is the first in the first period while history is taught in the second period, fifth period, and there is certain question that is a certain number of periods that we have, and we have certain subjects that are taught there. So we need to find at for which period there is a science teacher. As a science teacher you need to teach. Okay, so firstly we need to do according to the question what is mentioned in the this particular question. So what is mentioned, that is English is taught in economics is taught in the first period. So let's have five periods there, that is 1 2 3 4 5. Okay, and that is the five periods there. Then economic is taught in the first period, so economics. Okay, then we have been given while the history is taught in the fifth period. So we have history in the last period. History, right? What we have been given the next is English is taught between the economics and mathematics. So English is somewhere between economics and mathematics. And for science is taught before history. So before history, but immediately after mathematics. So if we consider mathematics here, maths here, and if we consider the English is taught between economics and mathematics. So English should be between here. That is English and maths. English, economics and maths, right? This is maths. Then there is only one period left, that is science, and we have followed all the conditions there. That is economics is the first period, history is the last period. That is the first condition. That is history is the last period, fifth period, and English is taught between the economics and mathematics. That is also followed. That is maths and economics. And next condition is science is taught before history and immediately after the mathematics. So that is also followed here. So as a science teacher you should be teaching at the fourth period. Clearly we can see that this is the first period, this is second, third, and this is the fourth period. So the our answer is in this particular case is fourth period. So that we need to do here is. Now moving to the next question. In how many ways the letter wizards can be arranged to make 7 letter words such that none of the letters repeat? So we are given a certain word that is wizard, Wizard. As we can see that wizards, right? So as we can see that all the characters in this particular word are different. So we have seven different characters, right? So if we have to make all the words from this seven characters, so we can have 7 factorial options that we can opt for, and 7 factorial is clearly 7 into 6 into 5 into 4 into 3 into 2 into 1. So that is clearly equals to 5040. So that is our option given, that is 5040. If we have certain characters and all are different, so we can have 7 factorial different choices how we can arrange these characters. So that is 7 factorial. So I think it is clearly okay. Moving to the fourth question here, that is 8 friends, Adam, Bob, Charlie, and these are 8 friends, and they are sitting around a round table and facing to the round table, and there are certain conditions that we need to follow, that is 6 conditions, and we have to tell who is sitting at third to the right of Adam. So let's have a round table, and then we'll be following the conditions there. So let's suppose this is the round table and we have 8 friends. So let's suppose these are the 8 friends. These are the 8 friends, right? So what we have said there in the first condition, Dev sits third to the left of Adam. So let's suppose Adam is sitting here. Adam. So since they are facing to the front of table, so the left side will be this side. So the Dave sits third to the right of Adam, third to the left of Adam. So third will be at this position, and they will be sitting at this position. From the first condition we have done. Now moving to the second condition, Eva sits immediate to the right of Adam. Eva sits immediate right of the Adam. So right is at this side, and immediate right means next to the Adam. So we are also done with this condition. Now Bob is third to the left of Dev. Bob is third to the left of Dev, and left side is this side. So third to the this will be the Bob. Okay, we are also done with this. Guinea second to the right of Bob. Second to the right of Bob. So Guinea is at this position. Okay, we are also done with this. Now Charlie is immediate right neighbor of Bob. Charlie is immediate right neighbor and of Bob. So Charlie is at this point. Right and immediate right. Okay, so this condition is also okay. Now Charlie is third to the left of Harley. So Harley should be at this position, so the third position will be Charlie to the left. So this is Harley, and clearly we are left only with one seat that will be occupied by Franklin. Okay, so this is the sitting position, and then we can easily find who amongst the following is sitting to the third of Adam. So sitting to the third right of Adam, and if we can see, that is the Charlie, that is from the right side and the third position. So Charlie is the answer. Now moving to the next question. If you have minus the simple interest and the compound interest of a certain sum of money, we are not given the sum of money here, and we have been given the certain condition. If we subtract the compound interest and the simple interest, we'll be getting the value 2, the value that is 2, if we are given the certain money for a year or 2 years and at an interest rate of 4%. So for the solving this question, you need to be have prerequisite of the formulas of simple interest and compound interest. So simple interest is clearly SI equals to P into R into T upon 100. We have all learned this particular formula. So applying this formula in this particular given condition, we are not given the P value, that is the principal value, and we are given the interest and the time value. So P into interest is 4% and the year is 2, and this will be the simple interest for this particular value. Okay, similarly finding the compound interest is P into 1 plus R by 100 to the power the value T, that is the time taken, minus the principal value. So this is the compound interest formula, and applying to this particular question, P is not given, so P will be as it is. Now 1 plus R is 4 by 100, and the interest for the year is 2. So let's have this. The year is 2 and now P is not given. So if we solve this particular equation, we will be getting 51 P by 625. While solving, you can check the solving, and you will be getting 51 by P upon 625, right? Now for this you will be getting uh, the value that is 2p upon 25. So what we need to do, we need to subtract these the interest, that is simple interest and compound interest, and the value is 2. So ci minus si, and the value is 2. So we need to apply this particular condition, and here we are given the ci value is 51p by 625 minus the si value, that is 2p upon the value 25, right? So when you subtract these, you will be easily getting p equals to the value 1250, and that is our answer, that is 1250. If you solve this particular condition, that is this particular equation, you will be this is particular equals to the value 2. When while solving, you will be getting p equals to 1250. That is the sum money that we have initially. So this is the kind of approach you can follow here. Now moving to the next question. Okay, so we have done with a fifth question. Now moving to the next question, that is here we have not got the exact question. Okay, now moving to this particular sheet. Okay, so here we are given the question as okay, we are given the question as we are standing on a green cell, that is this green cell, and in one move we can move to any yellow cell adjacent to that current cell. Okay, and we are given we can move in any direction, that is up, down, left, right, any direction, and we are not allowed to move in the move outside the table, and we are not also allowed to move in the blue cell. So we have to find the path so that we can reach from green cell to the red cell, and following the condition that we can't move outside of the this particular grid, and we can't also move to the value blue cell. Okay, so we have to find the minimum path length. So if we can see, the minimum path that we can trace here is moving to from this point, that is this green to this yellow, that is 1. From this yellow cell to this yellow cell, this is the 2 value, then 3, then 4, then 5, then 6. So we can easily find that the minimum value that we can achieve here is the value 6, and that is our answer. Okay, now moving to the next question. That is by how much percentage will you attain a profit or loss if you cost if the cost price of a certain 15 tables is equal to the 20 tables. So CP of means we are given 15 tables, CP is equal to 20 tables SP. Means the here we can easily find that the cost price of one table is more than the selling price. So we are easily getting a loss here, since the cost price is more and the selling price is lesser, because in certain money we are getting only 15 tables, and we are selling in that certain money we are selling 20 tables. So we are clearly having a loss. And for finding the loss percentage, what we can do, loss percentage is equal to loss upon the profit, means the CP value into 100. Okay, so we can see if we initially have, let's suppose the value of particular article is 15, that is for what we have bought 15x, and it is clearly equal to the 20 into y for what we have sell one table, right? So from this particular condition, that is 3x equals to 4y, right? And from this 4y, from here we can easily find the y value, that is 3x by 4, and it is clearly lesser than the value x. So we can from this point also we can easily find the we are getting the loss value, since 3x by 4 is lesser than the value x, so we are incurring a loss. And for finding the loss percentage, loss percentage, right, it is equal to the losses we are making, that is x value we are getting, and the loss the for what we are selling 3x by 4, and dividing it by the same value, that is the value what we have bought for, and into 100. So this is finding the loss percentage, and it is clearly is equal to x by 4 upon x into 100. and if we easily find, it is equals to the 25%. So this is easily given, that is we are incurring a loss of 25% from selling 20 tables at the same price of 15 tables. So this is the logic that we are following here. Next, the question is, x is a positive 4-digit number. Find the largest value of x such that on dividing 5 with 5, 6, 7, it gives the remainder 0. So it is a kind of a problem you can approach, that is from its last position, that is 9999. Now you can start checking the values, if the particular given this value is divisible by all or not. If it is divisible, then you can return that particular answer. If it is not divisible, then you can decrease the value by 1. That is, for next you can check for 9, 9 and 9, 8. And if it is divisible by all three, then you can opt for this, and if it is not, then you can decrement the value while you are not getting the number that is divisible by all three. So it is a kind of hidden trial method that you can opt for. And if you consider for this particular question, then you can easily see that if you divide, that is the value, you can also have a hidden trial on the options as well. We are given the options, that is, if let me put that is 9870. Okay, and if we divide by it 5, we can clearly see that at the last we have 0, so it is clearly divisible by the value 5. So for checking 5, it is not required. Now for checking 6, let's divide it by 6. So this is the value 1, then 3, 8 and 6, 2, 7. Then we are left with the value 4 and 3 and 0. So it is 1645. It is clearly divisible by the value 6. Similarly, 9870, it is also divisible by the value 7. If we can clearly check, that is 1, then 28, that is 4, then 1, and it is 0. So this is the value that we are getting if we divide it by 7. So the value 9870, it is clearly divisible by all three values, that is 5, 6, 7. So this is our answer in this particular case. It is a kind of a hidden trial method. And then the last question is, uh, if the third part of sixth part of the x is 15, then the 6th by 10th part of x is. So here we are given a certain kind of, that is part of a certain number, and we have to find the value x here, and then we have to find the 6 by 10 of that particular value x. So initially what we have been given, that is 1 by third part. So when we are given this kind of question, that is 1 by third part of 1 by sixth part of that, so in that case only we have to do is we have to multiply all these values, that is 1 by third with the value 1 by 6, that is sixth part means 1 by 6 of x. So x will be multiplied, it is given as 15. So now what we need find is that we need to find the value x. So x is 15 into the 6 into 3, that is 18, and it is clearly equals to the value 270. So once we have got the x value, what we can do that we have to find 6 by 10th part of x. So 6 by 10th means 6 by 10 into value x. So x is now replaced by the value 270. So this is the value 270. Now we can easily find the value, that is 162 will be our answer in this particular case. So this is the MCQs part I have discussed. If you have any question, you can ask, else we'll be moving to the coding part, right? Can we have a quick +1 in the chat if you are okay with this particular MCQs part? If there is any question, you can ask as well, else we'll be moving to the next question. Can we have a quick +1 in the chats? Okay. Okay, thank you, Aniket. Now moving to the coding part. We are the first question, very first question we have got in this particular contest is max min sum problem. In this problem, what we have been given is we are given a array of size n, and we have been given certain condition that we need to find the sum of maximum and minimum elements in the given array. So let me explain from the example as well. We are given array that is minus 2, 1, minus 4, 5 and 3. So what we need to find, we need to pick the maximum element and the minimum element, and then we need to sum those elements, and then we need to return the result. So the minimum element in this particular array is minus 4. As we can see, that is the minimum value is minus 4, right? And the maximum element is this particular array is 5. So when we sum these two values, that is 5 and minus 4, it is clearly equals to the value 1. That is 5 minus 4 is equals to the value 1. That's what we have to return. And the expected time complexity is n log n, and the expected space complexity is O of n1, right? So it is a kind of obvious question that we have got. So let me explain from the uh, okay. Let me explain from the example. Uh, let's have a quick example here. Okay. Let's suppose we are given the array as array is equals to uh, minus 10, 5, 7, 11 and uh, minus 11, right? So what we can do is we need to find the minimum and the maximum values. So for finding the minimum value, we can easily get the minimum value is minus 11 and the maximum value is 11. So this is the minimum value and this is the maximum value. Okay, so we need to sum these two values that we need to return at the end. So the minimum value is minus 11 and the maximum value is 11. So when we sum these two values, we will be getting the value 0. So for solving this particular question, we can have multiple approaches. That is, we can have the loop, that is for loop, and then we in one for loop we'll be finding the maximum value, keeping track of the maximum value, and then in the other loop and we'll be keeping track of the minimum value. So using the two for loops, we can easily get the maximum and the minimum values, and then we can easily sum those two values. So that can be the one approach. The other approach can be that is from I0 to n, and the maximum minimum values will be tracked. The other approach, that is second approach, can be using we can sort the particular given array, and then when we can easily find the sum of maximum minimum. That can be the very first part, that is very first index of the array, that will be the minimum, and the very last index of the particular given array after sorting is the maximum value. So if we sort, that is the sorting approach, and it will be taking the time complexity of n log n, since we have to sort this particular. So after sorting, the array will be minus 11, minus 10, and then 5, 7 and 11. So now what we can do, that we can easily sum the array of 0, that is the minimum value, and array of n minus 1, that is the maximum value, and we can easily sum these two values to get our answer. So in this case it will be equal to 0. That's what I have applied the approach. Let me show you the approach here. Firstly, we are given the function, that is solve function, and we are given the array as a vector there, and we need to find the sum of maximum and minimum value. So here we have found the size, that is n equals to nums dot size, and then we have sorted the given array, and then what I have told you, that we'll be summing up the last value and the first value. So we are having the sum value equals to nums 0 plus nums of n minus 1, and at the end we are just returning that sum value. So let me compile this particular code. So as we can see that our expected and our output is same. So let me submit it. This for submission also it is okay. So if you still have any doubt, you can ask in the comment section. I will be actively checking those comments. And till then, I'm moving to the next question, that is whack-a-mole. And yeah, it is a kind of hard problem that we have got in this particular question. So let me explain the question first, and then I will be discussing the approach. Okay, So what we have been given is we have been given a game, that is whack-a-mole game. In this particular game, what is given, and we have been given n moles numbered from 1 to n, and left to right. Okay, this is the given problem, and each mole comes out of at a certain point of time, that is AI seconds, and then it goes back instantly. Okay, means it comes out and goes back. So at a certain time period, each mole has its certain time period that it comes out. So we have to kill the all the n moles, and we have to find the minimum time so that we can kill all the moles. And we have been given certain one more condition, that is we can't kill more than one mole at a particular time. Okay, we can't kill that. This is a particular condition. You can't kill more than one mole at a particular time. So this is what we need to follow, and we need to find the minimum time so that we can kill all the moles starting from t equals to 0. Okay, so for this solving this particular question, let me explain from the question as well. Okay, let's have a new window, that is okay. So what we are given is we are given a certain game. Let's suppose this is the board, and each time we have certain moles there. Okay, let's suppose these are the moles. Okay, each time we are at this certain point, and we are observing when a certain mole comes out, we can easily kill that particular mole in that same time, but only we can kill only one mole at a time. Okay, and every mole has its certain time, that after a certain period of time the mole comes out. So we need to find the minimum time so that we can kill all so that we can kill all the moles. We can kill all the moles following the conditions, that is all the moles. We have been given the conditions, that is each mole has certain time it will come out, and the other condition is we can't kill more than one mole at a time. So let's consider the same example. We are given the value 222, and we are given 3 moles, right? So let's remove these 2 moles there. Okay, let's have 2 moles, right? 3 moles, right? And we all have time period of 2 seconds. Okay, so the very first second what we will be getting is we'll be getting in the first two means the second, that is second, we'll be getting all 3 moles, and we can kill the one mole. Suppose it kills the first mole, so now first mole is killed, and we are already past 2 seconds. Next for the next 2 seconds we'll be not getting any mole, and when the time is t equals to 4 second, we'll be getting 2 moles again. So these 2 moles will be again there, and one mole let's suppose is again killed. So now we are left only with one mole, and the time we have already passed is 4 seconds. Now the third mole is left, and it will be have a cooldown period or the stay period as 2 seconds, and at the 6th second, that is 6 second, we'll be getting again the mole that will comes out, and it will be again killed. So at the 6th second all 3 moles will be killed, and we won the game. We win the game. So this is the kind of question. We need to find the minimum time that we need to keep track so that all the moles are killed. So this is the given example in the particular question. So as we can see, the output is 6. That is for the second we can kill the first mole. Then for the t equals to 4 second we can kill the second mole, and for t equals to 6 second we can kill the third mole. Now moving to the next question, next example, that is 3 2 1. In this particular example, at the first second we can kill the third mole, that is since it has the waiting time as 1 second, so every 1 second it will come out. So we at the very first second we can kill the first mole. At the second that is t equals to 2, we can kill this particular mole, at it will come out of the in the 2 seconds. So we can kill in 2 seconds, we have killed the third and the second mole, and at t equals to 3 we can kill the first mole as well, because it has a time period of 3 seconds. So in 3 seconds we can kill all 3 moles there. So this is the kind of problem that we'll be approaching here. Yes. So we can have a certain approach that is here we need to follow. Okay, let's remove this. So what we need to follow here is our approach is pretty simple, that we'll be making a priority queue there. Priority queue because so that we can keep track of the minimum time mole, so that we can kill that particular mole in the given time. So priority queue here is we'll be using the minimum priority queue or min heap, right? And the min heap will be storing priority queue. So minimum priority queue will be holding the top node or the top edge, means the top very first node will be the minimum time we'll be getting the next node, and next mole will be killed and it will be popped out, and again the next mole will come at the top and it will be killed, it will be popped out. So this is kind of the approach we will be following here. So for following this particular approach, what we'll be doing, uh, we'll be pushing all the we'll be having a pair type of priority queue, and let me explain the logic first, and then I will be showing you the why I have done this particular intuition there. So in priority queue we'll be having a pair type, and each pair will be the int comma int. Let's suppose that we have the pair int comma int type and pq, right? And each time what will be we'll be running a loop for the whole length of the given array, and we'll be pushing pq dot push. We'll be pushing array of I, that is the given element, and minus of array of I also as well. Minus of array I is means I will be telling you in the certain time why I have pushed this particular, that is minus array of I as well. So once we have pushed all the elements, then while the pq is not empty, means all the moles are not killed while not pq dot empty, uh, we'll be checking certain conditions. So let me show you the code so that you can better understand it. We have the pair type priority queue, that is minimum priority queue, and we have pushed all the elements, that is array of I, with the negative pair also, that is a of I means minus a of I as well. Once we have pushed into the priority queue, we'll be initially declaring the total time we have taken as 0, and then while the priority queue is not empty, means all the elements are not killed, that is moles are not killed, we'll be having the auto p, that is the top of the priority queue, and then we'll be popping that particular element, and then we'll be checking if that the first element, that is we have array of I, we have pushed at the first, that is at this point, if the first element, if it is lesser than the total time, means let's suppose we have the example, total time we have done is 4 seconds, and the mole time, that is the first time we are getting, is let's suppose 2. If it is 2 and total time we have already passed as 4, so in that particular case what we need to do is we need to push that pq dot push the first value, that is pq dot first value, and the second value, that is addition of that is subtraction of both. Here we have done the subtraction because since we are doing the we have taken the negative value, so we can subtract it from the positive value, and when we are subtracting that negative value with the positive value, it will be at the end giving the sum value. So let's suppose we have the 2 value at the pq dot first and pq dot second is -2. So while subtracting, it will be the first value will be pq dot first plus pq dot second, that is the 4 value, and the pq dot second in each case will be the same value that we have -2 initially. And means the if the this particular condition doesn't match, that is p dot first is not lesser than the total time, means we can have the mole out of the board. In that case we can kill that particular mole, then total time will be p dot first, that is the first value that we have in that particular mole, for that particular mole. So because it is getting killed, so the total time till that will be getting is p dot first. what I can explain from example is, let's suppose the mole as first time, that is first value as 4, and the second value is -2, right? So if the total time is lesser than that, or the initial total time is 4, let's suppose 3, right? If the initial total time is 3 and we have the next value that is 4 is coming out of at t equals 4, we are having a next mole. So the next time we can have, since it is the top of the priority queue as well, so what we can do is, since it is also the top, so now total time, since this mole can be killed as well because it is coming out of at the 4 second, and initially we have passed 3 seconds, so this mole will be killed because it is at the top, means the next mole we are getting is this particular mole, and it is having the time greater than the total time, so this particular mole will be killed, and now the total time we have taken for killing the particular mole is 4 second, right? So we'll be updating that time with the that. If let's suppose total time is 5 seconds, and the first time we are having is 3 seconds, so since this mole can't be killed at this particular time, because 3 is not because it will be at coming out of the board it in every 3 seconds at a frequency of 3 seconds. So for having this particular time, what we can do is, we can add this particular time in this, and then we can check, push into the priority queue, and whatever will be coming next will be at the top of the priority queue, and that will be killed. So for the next duration, -2 will be added this particular condition, and this will become 5 comma -2, and each time if we are not killing that particular mole, then we'll be adding the negative, that is the second value, into the first value, so that the time increases, and once we have killed all the moles, we'll be getting the total time updated in this particular variable. So I think you have got the intuition here is, we'll be considering the priority queue here, because it will be holding the minimum mole time that we are getting at the top, and once we have killed the minimum mole time, minimum time mole, we'll be getting the next mole that we can kill, and if that particular mole time is means lesser than the total time we have already passed, in that case we'll be increasing its time, that is we'll be having its next cycle, after how much cycle it will be killed. So for having the next cycle, what we are doing, we'll be having the p dot second added to that first value, and we are only the concept of having the second value p dot second is so that we can keep track what was the initial value by what that mole has the initial time, so that we can add those values for the next cycle as well. So for adding that next cycle, we are subtracting it from this, since it is a negative value, so we are subtracting so that it can be at the end added to that first value. And since we have pushed, we are not having that particular mole in this particular condition so that we can kill, so we are just pushing this particular into the priority queue, and next the priority queue will be managed there, and the minimum time will mole will be at the top, and for the next iteration, when this particular condition fails, that is the total time is now lesser than, should be lesser than the value at first position of the priority queue. If it is lesser, then we can update the total time as the p dot first value, and at the end, while all the moles are killed, we'll be having the total time in our total time variable that will be returning at the end, since we have initialized it with the value 0. So the total time value will be at the end that we have to return. So let me compile this particular code. So for compilation it is okay, that is our output and the expected output are same. So let's submit it. Yes, for submission also it is okay. So I think it is clearly understood question. Okay, what I can say is, I can explain it again, so that if there is anything missed, you can easily get into that. So for approaching this particular problem, we have to, since we have to kill all n moles in a minimum time, and each time if there are certain moles that is out of the particular board, and we can only kill the one mole at a time, right? So since we can kill only one mole, we need to have the mole that is having the minimum time there, because if there are certain moles and there are having certain different times, that is the maximum values. So we need to keep track of the minimum value so that the total time doesn't increase rapidly. So for having the minimum value, we have maintained the minimum priority queue, and the minimum priority queue top will be giving the minimum mole time, that is by the first value, and that will be giving our answer. So we have to once we have pushed all the elements with the negative values as well in a pair form, while the pq is not empty, means all the elements moles are not killed, we'll be popping the top value, and each time we'll be checking if the first value that of that pair, if it is lesser than the total time, means as we have already checked, that is total time is, let's suppose, 4, and the pair first value is 3. So that can to be killed because the p dot first value is 3, so it comes at the every 3 seconds, and we have already passed the 4 second, so we can't kill that. But if we have already killed, then it will be already eliminated from the priority queue. If we have not killed that particular value, then it should the time should be updated there. So for updating the time, we have what we have done, we have updated the first time. So first time is updated by p dot first minus p dot second. P dot second is subtracted here because we have the value that is minus, and when 2 that is minus of minus is added, it is added to the sum value. So p dots it is kind of a p dot first plus p dot second value. So p dot first and p dot second, so that time is increased for the next for the next iteration of this particular mole. That is, if it is having a time period of ai second, that is 3 seconds. So the first for the first third second it will be come out. If it is not killed, then at the 6 t equals 6 second it will come out, then t equals to 9 if it is not killed. If it is killed, then we have eliminated that particular mole. If it is not killed, then at every frequency of 3 seconds it will be coming out. So maintaining that frequency, we have pushed, that is p dot push p dot first minus p dot second, and p dot second is already mentioned, that is the initial value, so that we can recall what is the initial value. We don't have to check each time the ai value, because for maintaining, if we are checking from the array what was the initial value by what we have to increment, then it will be a quite complex task, because we can't know for what particular index the top element is. So for maintaining that particular values, and keep tracking what was the initial value, by what we have to increment that particular value, we have maintained the p dot second, that is the negative value, so that we can add each time if it is not killed. If it is killed, then will be total time will be p dot first, and at the end, well, all the elements, that is all the moles are killed, total time will be having the answer. So we have written that particular answer. I think it is clearly understood for this particular question. If it is understood, can we have a quick plus one in the chat, or if you have any doubt, you can ask as well. After that, we'll be moving to the next question. That is the last question of this contest. Okay. Uh, when will the final rank list will be validated? You will be informed about that. So you need not to think about how the comments will be go. If you have any doubt, you can ask in the comment section. I will be actively checking that. And yeah, okay, let's have a 1 minute break there, and then we'll be moving to the last question. Okay. Okay, now moving to the last question of this particular session, that is minimum maximum partition, right? So in this particular problem, we are given a certain, it's a kind of a good question that we have been given. Here we are given a string of size of length n, and all the characters in this particular string are lowercase, right? And we are given a function that is fk, and fk is what, it is a kind of a function where we have to return the maximum frequency character, and what is its frequency. So let's suppose we are given the string as a, that is 3 times a, then 2 times b, and 1 times c. Okay, so what we have to find is, since we are applying the fk function, so it will be giving the frequency of the most frequent character. We can easily see that the most frequent character's value a, that is appearing 3 times, and the value that we have to return is 3, because it is occurring 3 times in a particular given a string. So the fk value is clearly the most frequent character that we are getting in a particular string. So the task we have to perform is, we are given a string and we have to partition it into k contiguous parts. That is, if we divide, we can have the partition here, that is for a, then we have a partition, then the other string will be bb, then the other string will be c. So we have two partitions, or the three strings at the end. So we need to have k partitions, and such that we have the maximum value of f of s1 s2, that is all the partitions, is minimized. Maximum value will be, fk value will be, we can easily find whether this particular, that is most frequent character in a particular string, and for all the all those strings after partition, we will be finding the maximum values most frequent characters, and that maximum value should be minimized. So that is our task that we need to perform. So as we can explain, I can explain from the example as well. If we have the string that is a b c d e f g h, right? So if we have three partitions, that is, we have been given k equals to 3, so we have to partition the string into three strings: a b c d e f g h, right? Let me again check whether this is a b c d e f g h, right? This is the given string. So if we partition this particular given string at this point, a b c d e f and g h, so we can see that the most frequent characters in this particular is, every character has a frequency of 1. So f of k for this particular value will be equals to, f of s1 means, will be equals to the value 1, that is every character has a frequency 1. And for this particular also, f of s2 will be equals to, since the frequency of every character here also is 1, so it is also 1. And for this particular string, here we can also see that every character there is occurring one time, so f of s3 is also 1. So when we find the maximum of f of s1 s2 s3, it is clearly equals to the value 1. So maximum is equals to 1. That's what we have to return at the end. Let's consider the second example as well. If we are given the string as a means 4 times a and 4 times b, and we have been given the k value as 2, so we have to certainly do two partitions, and we have been means then we have to find the maximum value of f of s1 and s2, right? So if we partition at this particular point, that is, let's consider this example. If we have the value a, then b as well. So we can clearly see that we have two partitions, and for this f of s1 will be, since all the characters are same and the frequency is 4, so the most frequent character is a and the frequency is 4, so f of s1 is clearly equals to value 4. And for this particular, since the most frequent character is value b, character b, and the frequency of each character is 4, that is frequency of b character is 4, so we can have the f of s2 as well 4. Then we need to find the maximum of both, that is maximum will be equal to the value 4. So maximum in this particular case will be equal to the value 4. That's what we have to return at the end. Okay, so this is the approach, this is the question that we have to perform. So for approaching this particular question, we can think of approach where will be doing certain the practices of the binary search. It was a kind of a question where we can apply the binary search for solving this particular question. Let's explain. Let me explain how you can approach this particular question using the binary search concept. Okay, so what we have taken is we have the initial, that is n equals to the s dot length, and that is initially length, and then we have the low value and the high value. So low will be initially at this the first particular index, and the high will be at the last index, right? So low is equals to 1 and high is equals to n. Then we have the minimum initially, and that we have done minimum initially as the value n, right? Then what we'll be doing here is while low is lesser than high, this is the kind of binary search condition. Means while we have not checked all the elements, we'll be performing this, and then we'll be finding the mid value. So mid value is low plus high upon 2, and then we have frequency array each time, so that we can have the frequency of each character, and whichever will be the minimum maximum at the particular condition, that will be our the most frequent character, and will be returning its frequency. So that is the kind of approach we'll be following. Means we'll be keeping track of the frequency of all the characters in a certain partition. That is for each partition we'll be having a frequency array. Let's suppose we have the partition that is a b c a sorry a, and then we have the d value. So this is the first partition, and the second partition is d e f. Let's suppose we have two partitions, right? So for each partition we will be having the frequency arrays, that is okay. Once we have the frequency array, let's suppose this is the given size frequency array. Once we have the frequency array, we'll be storing the frequency of each character. So for A, the frequency is 2. For B, the frequency is 1. For C, the value is frequency of the character C is value 2, value 1, and the frequency of character D is also 1. So for first partition, the maximum, if we apply f of s1, that is the first partition, we can clearly see the maximum value is what we are getting is the value 2. So we can keep track of the maximum value at what we are getting for this particular partition. And once we have this partition value f of s1, then we'll be finding the value for the next partition as well. And for the next partition, the value of, that is d value is 1, e value is 1, and f value is 1. So we can easily find that f of s2 is, that is the maximum character frequency is 1 in this particular example. So when we find the maximum of f of s1 and s2, maximum of f of s1 and f of s2, what we'll be getting is the value is 2, since the value of s1 is 2 and the value of f of s2 is value 1. So we'll be returning the maximum value at the end. So for each partition, what we have to find is we have to have a frequency array, right? So that's what we are maintaining here is for each partition we are maintaining a frequency of array of size 26 because we have 26 alphabetical characters there, and for each character we'll be having the frequency, right? We have run a loop. Initially the count values, that is the partition that we can perform is k, and then for each character we'll be incrementing its frequency, and then we'll be checking if the frequency of particular character, that is if it is greater than the mid value that we have initially found. Mid value here is the kind of a partition that we are performing. If it is greater than the mid value, means it is a most frequent character, then what we'll be doing here is we'll be filling all that frequency from starting to the end, that is the frequency array we will be reinitializing with the value 0, and we'll be decrementing that particular count, since we have got the first partition value, and that is the first value of fk1 or f of s1. And once we have got the first value, we'll be checking if count is greater than 0, means we have done certain partitions. If we have done certain partitions and we are not going to the value that is count is lesser than 0 or certainly other value, then what we will be doing, each time we will be decrementing the high equals to mid minus 1. High will be decremented to mid value minus 1, and minimum will be updated, that is minimum will be mid mini comma mid value. mid value, since the frequency of uh, particular character is greater than mid. So what we'll be doing is the mid value will be the maximum that we will be getting the frequency of the particular character. So for each character we'll be doing this particular conditions, and while we'll be performing, while the low value is lesser than equals to high value, we'll be performing these conditions, and whatever will be stored at the end in the min variable, that will be our answer. So the min value here, we are performing all the type of partition we can perform at particular point. We can try all the partitions, that is at the first position, then second position, then certainly we will be checking if we have done k partitions, then we'll be checking the minimum value, maximum value of fk1, f of s1, f of s2, and whatever will be the maximum value, that will be returning at the end. So we have to try all the partitions, we have to try since we have to try all the partitions, we will be getting the different values of f of s1 and s2, and that's what we have to explore. And once we have done all these calculations, at the end we'll be getting the minimum variable at the end in the min value, and that will be our answer. So this is the kind of approach that we'll be following here is. And yeah, let me compile this particular question. Yeah, for this particular question, our expected output and our output is same, so let's submit it. Yeah, for submission also it is okay. So I think I'm done with this particular question also, and we have done all three questions, and we have done the MCQs as well. And if you have any doubt, you can ask in the comment section from any question, if I have missed any view, or if you have certain questions, certain queries, you can ask. uh, and yeah, I'm done from my side. So, and what I can say is you can participate in the next contest as well. It will help you to get the insights how the contest actually looks, and you will be getting certain rewards as well for participating as well. And if you get a good rank, you will be getting the certain rewards. So I think you will be participating in the next contest as well, and the GFG will be confirming the next contest details and the dates as well, so that you can participate and have active participation in the next contest. And you can expect the similar kind of questions, a similar level of questions in the next contest as well. And for if you have any doubt, you can ask in the comment section anytime. We the team will be reviewing the comments, and will be uh, uh, posting the solutions of this particular queries. So till then, let's move to the let's end this particular session. And yeah, if you have any queries, you can ask. Okay. Okay, so let me end the session, right? Thank you.